I'm Stuart Hayward-Higham from SITA, and UKTI have asked me just to come and have a chat around some of the stuff we're doing, including cement and a few other things. So we'll have 20 minutes and then we'll have a chat maybe at the end. So you may well ask, what's innovative in waste? We've been collecting food waste, we've been collecting rubbish, moving it, disposing of it, making energy for many years. So I'm here today just to dispel that some of us and the industry is actually quite innovative. Some of the things we're doing are quite good. But to understand what we're innovating in, you have to understand where the market's moving. So you can see here just SITA predictions, and I say this in all my processes, all predictions are wrong. So anyone who gives you a prediction, the first thing you'd say, that's wrong, because we'll all get it wrong at some point. But you can see here, increasing recycling, but quite a significant growth in thermal. And that's all thermal. So that's traditional thermal, that's SRF, that's RDF, that's cement works, that's biomass and all the other things. So quite a lot of movement in that process. And if you break that down and say, okay, what do we think is going to move? So here, 2015, 2020, 2025, and again, I remind you, every prediction is wrong. You can see that we've got a growth in advanced conversion, a lot more gasification, pyrolysis, that sort of process. Solid, slight growth in cement, biomass, MBT, mechanical treatments, the whole process. So you've got a range of new technologies, new processes, a lot that are very sensitive to the feedstock. For many years, we defined waste as waste, and then we decided we'd class it as recycling and residual. And now we're speciating it down to CVs, contents, ashes, moisture contents, biomass. So ignore waste and think fuel. And when you're thinking fuel, you're thinking, okay, from your residual waste, what can you make? Well, you've got biomass, which is organic textiles, you've got paper, you've got card, you've got plastics. And then you go through refined fuels, you go through crude fuels, clean organics, dirty organics, wood, dirty wood, clean wood. So all that process going on. And we're talking about the energy potential. We're talking about how much energy is in there. And one of the things we see is that people think about waste in tons only. But actually, if you think about it in joules, then when you're looking for higher joules, you get less tonnage. So when you're looking at capacities and things like that, you have to make those trade-offs and those balances. But when you're making a fuel, you don't just take something and process it, because that's quite expensive. So what you're looking at is you're looking at feedstocks. You're trying to say, okay, which sectors, food sector, professional services sector, give me what type of waste, how that waste works, what the CV is, what's going to change in it. And then you're saying, okay, how do I blend that? Can I have 3 loads from this sector and 2 loads from that sector and do the minimal amount of work in the middle to make my grade of fuel? So you're getting into low-grade, high-grade work. You're looking at municipal waste, standard CNI, high CV CNI. So you're saying, okay, that sector gives me high CV material. I need 2 loads of that because I'm producing fuel for a high-grade customer. But you've also got to test it. There was a recent report from DEFRA that tried to back-analyze the biogenic fraction of residual waste by deducting from it the things that we now recycle. A lot easier if you test the material you produce and say, what's the biomass content? Because that's the renewable part. And you can see, that's our Landor Street, just how consistent the biomass fraction is when you're blending different feedstocks going in to make a renewable, consistent fuel. And unfortunately, the sun's there, but if you look at that, it's consistently over 50%. So we're making high-grade fuel facilities. Start off with blending like any recipe, put it in, and then you're processing it, and you're making very light-grade fuels, very high CVs, and you're building very complex pieces of kit. So this is our Landor facility just down the road in Birmingham, and you've got the process of loads coming in, booked in. We have a small reception area, making sure that we're doing just-in-time deliveries. We're blending those fuel stocks, so we're putting 1 load of that with 2 loads of this, with 3 loads of that. Putting it through the process, we're taking out the inorganics, we're shredding it, we're measuring online for CV, we're measuring online for PVC and for moisture content. We're feeding that back to our picking line, who are defensively picking the materials that we don't want in the fuel. And then we're taking samples of the material, we're testing that continually. We give it to our customer down the road at Rugby, they test it as well, and then we get together and we start to put the two tests together and understand what the trends are. And again, sage advice, every single test we do is wrong, because on its own, it's only representative of the material. But when you've got a few hundred samples, you can start to get a very good, consistent profile of the material you're making and the fuel you're making. We're starting to see from some of the results, some of that process, things like PVC seasonality. So you see PVC going up at certain times of the year and going down. And you chase that back into the sectors and say, which sectors give me more PVC? Why are they seasonal? DIY is one. DIY and the boom in little construction that goes on, home construction. In Easter, remember those bank holiday weekends when suddenly B&Q and other people are advertising, that's when you start to see the material come back. Christmas, toys, come wrapped in PVC, come covered in PVC type material. But there's 2 or 3 others that we haven't yet identified. So you're then saying, well, actually, at certain times of the year, I don't want building trade waste coming in at the same rate because I have too much PVC, so I'll have 1 load rather than 2 loads. So your manufacturing process is saying, I'm blending my feedstocks to make my fuel grade. And you can see here, input qualities and the type of process that you go through to make it work. Shredding, sorting, and we've moved the shredder around. So we used to shred, then trommel, now we trommel, then shred. Produces less fines, gives us a more consistent product. So you're always blending and always processing. We put the material in an Arctic container and we ship it off every night. So we end up with just filling containers. We don't have big storage either. And then you're going this whole debate about making to a standard. We make a standard fuel to our customer's requirement. We don't follow a SEN standard unless they pick a SEN standard. We don't follow a RAP standard unless they pick a RAP standard. We pick their standard. There's no point making something generically. So you're going through the process, say, what is the standard? What do I make it to? And then you're consistently measuring it. These are the commissioning results from Landor. And you can see gradually becoming more consistent and becoming higher and working out the consistent and the biomass as well. So you're continually using those results to feed back into the processing system to understand how to make the material, how to tune it, and how to blend it back. But very much customer specific. And when we export materials, it's exactly the same. Be it SRS or RDF, it's about the customer specification drives, and they all have slight nuances about how that works. And it's now an internationally recognized fuel. 3 million tons, I think, is the fuel export potential for this year. That's exports, that's money back into the country in terms of savings on domestic usage. And now it's an international. Certainly SRF is becoming commoditized, and you've got people from India and other countries outside Europe going, we'd like some of this material. Why? Because it's a fuel and it delivers the energy that they want. And then cement companies are also targeting a gradually increasing tonnage in the same way as we are for Cemex. So Landor's built and operating. Malpass, which is a facility next to the Rugby plant itself, that's in build and will commission November, December this year. Together, 250, 300,000 tons of fuel. When you look at innovation as a sector as a whole, making fuel, making quality fuel is an innovation. But if you look at some of the stuff that's been going on, we've been making vehicle fuel from landfill gas with a partner for 8-9 years now. Successfully selling in that as a blended fuel or a pure fuel. We have a pyrolysis plant that's just in its commissioning phases at the moment that's converting end-of-life plastics back to things like kerosene, which is going to get sold off as an end-of-waste fuel. Organic waste treatment, looking at making lipids, ethanols, butanols, and other materials from the organics in those processes, making what we call a super soup, which is RDF, but wet. So imagine your caddy bin processed and energized so that it's really high energy potential, and we can get that material out. And if you take one part of organic waste, apples, if you look at an apple and deconstruct an apple, in there are things called polyphenols. Polyphenols are antioxidants that prevent cancer. They're the things that oxidize that make the apple go brown. So when you eat an apple, you leave it too long in the air, it goes brown. That's the polyphenols oxidizing. They're antioxidants, but they're worth something like 10,000 pounds a kilo. It's not a lot of kilos in an apple, but you've processed enough apples, you can get them. It's a really interesting process. But then when you look at a very energy-focused activity, in the waste industry, we've been quite good historically at making flies, inadvertently probably. But we've just finished a process in the Netherlands where we've deliberately grown maggots, and we take the maggots and we make protein feed for animals. And that's worth at least 2 times per ton of input the value of energy. So you're making something completely different. You're offsetting that energy potential with other things. So actually, there's huge amounts of processes going on. And if you look outside our business, there's a whole range of people doing really interesting stuff with waste and waste to energy. And if you look at the potential of our sector, this is just an idea. If you look at enzymes and using bacteria and algae, there's enzymes that will eat plastic, leaving you with what isn't plastic. So you put a keyboard in, you end up with the plastic being eaten and the components of the keyboard that are metal, and the components of the keyboard that are the rare earth metals falling out or floating out of the system. So there's some really interesting stuff about promotion, bacteria, making algae, and algae can then be used as secondary products for hydrogen and other materials, yeasts, and then using yeasts to make ethanol, and fungi to grow medical products on, that sort of process. So there's a huge range of things, and there are masses of people in the UK working on these types of projects. And then you look and say, okay, they're projects, they're real things, they're emerging, they work, but they not necessarily work well enough. And then you look at some of the other stuff in the wider industry, the agro industry, the chemical industry, the medical industry, they're all going down the route of what else can we make from this process? Chitin is made from shells, it's in lots of medical products. Hugely expensive material, ground from shells in the Caribbean. Well, actually, you can take chitin from material in the UK, from shells in the UK, but also from organic waste in the UK. So there's lots of materials that you can bring into the process that we're not making best value of. So the potential of making best value from waste is huge. And a lot of these are either energy displacers or energy makers. But if I come back to energy and say, okay, well, what is the contribution that UK PLC waste can make to our energy needs? I've got a graph here. The light green lines, that's the contribution that landfill gas has already made. At one point, landfill gas contributed 14% to the renewable content of UK energy power. That's in decline because we're diverting waste from landfill. So you've then got an upturn in the dark green in AD. And you've now got something like 140 working AD plants using food-separated waste through that process. And then you have another uptake, which is the orange lines. That's the growth in domestic energy from waste. That's how many plants are being built. Huge numbers of plants being built around the country by multiple operators that will contribute to UK baseload. Now, not all of this feedstock is green. So the top line is the total energy produced, and then this line here, the green line, is assuming 50% of the input is organic, is the green energy contribution. An awful lot of gigawatt hours of energy coming from waste. Huge amounts of input, something in the region of 10 or 15 billion pounds worth of infrastructure investment in the UK to use the fuels that we're making. So if I was then saying, what are we doing? We're learning skills how to manufacture fuels, we're exporting those skills. So we're now making fuels in Australia and exporting into Malaysia. That's UK skills translated overseas to make fuels. We're building gasifiers and pyrolysis plants so that we can make best use of the individual products, be it plastics, be it biomass, be it whatever it is. We're introducing new organic techniques that are helping us make better fuels or better energy or different energies. And we're looking at the next stage of inventions and innovations where we can start to move those. And if we can do them in the UK, we can export those skills overseas. So very much a very innovative, very mobile market.